So if you're watching this video, I assume that you know what significant figures are, because these are calculations with significant figures. And before you do the calculation section of this, you're going to have to understand what a significant figure is first. So if you don't know what significant figures are, or you need help to determine the number of significant figures in a measurement, then I would suggest that you go back and watch the previous video, because this is calculations using those. And in order to do this, you have to be able to determine the number of significant figures in a measurement first. All right, so calculations. Why do we do this? Why do we talk about it? Why do I waste time? Well, the answer here is that when we talk about calculations, and this is addition and subtraction or multiplication and division, these are typically done on values that are obtained in a laboratory. And these are measurements. And these measurements, or these values that have been obtained in the laboratory, these have significant figures that are associated with them. And we're getting ready to use these measurements, and we're going to add them, or we're going to subtract them, or we're going to multiply them, or we're going to divide them. And we need to know, how do we report the answers that we get from these calculations? So there's two different sets of rules here, which is why I wrote the addition and subtraction together and the multiplication and the division together. So this is going to be set number 1, and this is set number 2. So they do have different rules. We've got to figure out what we have. Once we figure out what kind of calculation that we have to do, then we go back to the rules that are assigned to either set. All right. So why is this important? Why do we worry with it? General rule of the mill here is that your answer from the calculation cannot be, and I'm going to underline that, cannot be more precise than your least precise measurement. I know that's kind of wordy. Bear with me. But that's typically what's stated. So when you do these calculations, you're doing them on measurements that have been taken in a laboratory in some form or fashion. They've been rounded off. And now we're going to add or subtract them, or we're going to multiply and divide them. And when we get these answers, sometimes the calculator is going to give us tons of decimal places with the number, or a really huge big number that we're going to have to realize how to handle that. So general rule of the mill, your answer from these calculations cannot be more precise than the measurements that you use to make them with. All right. So in other words, let's say that I take a ruler and I go measure a stick of wood. I mean, I don't know. I've just made that up. And let's say that I take that ruler and I say, well, this is 12 inches. And then I measure another piece of wood and I say, well, this is 6 inches. And we're going to take these two pieces of wood and we're going to put them side by side, and we want to know, how long is it? So I'm going to take these two values and I'm going to add them up. Well, you would do 12 plus 6, and that's 18. And you would say, well, that's 18 inches. You actually did not realize this, but you just did this with proper number of significant figures. It's an addition. There's a set of rules that go with an addition problem. And you looked at this and you gave me an answer of 18. And that's actually proper. That is what that answer is supposed to be in terms of significant figures. Well, what if we subtracted them? My first one's 12 inches. My next one, I cut 6 inches off. And you look at this and say, well, you've got 6 inches that's left, right? I mean, this is your typical addition and subtraction here. That's where we need to start. Because this is what you've always done. It's basically what you've always keyed into a calculator. You've been very comfortable with these values and these numbers. And it just so happens to meet the appropriate number of significant figures in these calculations. And we need to determine why. You know, did you get lucky? The answer's, well, yeah, kind of. You did get lucky. But I also think that it just makes common sense. And if you looked at these two values and you did 12 plus 6 and you gave me 18, I don't think any one of you would have been like, well, it's 18.000003 inches. If you did that, your answer is more precise than the individual measurements that took place. Why do you think it's okay to drag this number out that many decimal places when this number wasn't? And when that number wasn't, it doesn't make any sense. And that's because this value is now more precise than any of these other values that you used to actually make the measurements and the calculations with. We don't do that, right? So this is just a formal way to talk about the rules that we have to follow when we add and subtract numbers or when we multiply and divide numbers, and it gives us an idea of where to round these digits. The same thing's going to happen with your subtraction. You're going to take 12 minus 6. Most of you are going to write down 6. I don't think any of you would have been, well, no, it's 5.9999321 inches. You wouldn't have done that. That makes no sense, right? You are saying that this is way more precise and maybe a closer answer. You're going to bet your money on that number when you go to Vegas on the betting table. But if you look at this value and that value, these two are very simplistic. There's no decimal places after those digits, right? Just like there's no decimal places with the 12 and the 6 when we added them. So why do you think you need decimal places when you report the final answer? And you don't. That's not what this is about. So this is the idea of significant figures in terms of addition and subtraction. So the good news here is that when you add or when you subtract, you actually don't need to look at the total number of significant figures at all. The only thing that you have to do here is look and determine the number of digits after a decimal place. That's it. And your answer should be the least amount. So if I go back up to these other two examples that we did prior, you know, this has 0 digits after the decimal. This one's got 0 digits after the decimal. So I want to make sure that my answer has 0 digits after a decimal point. And with 18, we didn't even write a decimal point. There is nothing after a decimal point there. Versus something like this. That doesn't make any sense. I need to drop all of that off. I don't need to report that. That's not the proper number of significant figures with that calculation. The same thing happens with subtraction. There's 0 digits after the decimal. There's 0 digits after the decimal. So my answer will have 0 digits after the decimal. So if I ended up with something like this, then I'm going to make sure that none of those decimal places are going to be reported, and I need to round that number in order to make sure that it only has 0 digits after the decimal place. That is what addition and subtraction is all about. So let's go ahead and do just another example to kind of put this rule to the test. Let's say I've got 23.560, and then let's say in the other measurement that we have a 2.1. All right, so I'm going to add these two things up. Well, if I look at this first measurement, I've got 3 after the decimal place. And if I look at the second measurement, I have 1 after the decimal place. So if I added these values on a calculator, I want you to do that first, right? I want you to add these values just as they are on a calculator. This is going to end up giving us a 25.660. Okay, that is going to be your first step. It is normal math. I'm not changing any basic math rules on you at all. Now the only option that we have to do is that we have to go in and figure out how to round it off the proper way. So there's 3 sig figs after the decimal with our first measurement. There's 1 after the decimal with our second measurement. So therefore I use the least amount. So I need to round this off at 1 decimal place, and that is where my number needs to be rounded. So to make sure that my answer, because as it is right now, there is a chance that my answer is more precise than my least precise measurement. And I can't do that. Scientifically, I'm not allowed to do that. So I need to round it off. And by rounding it, I'll get a 25.7 as my final answer. Okay? All right, another example here, 0.0056. And we're going to subtract 0.004067. It's a subtraction, but it doesn't quite matter because it's going to follow the same rules that the addition used. So I'll just pull up this calculator so you can see me key it in. I'm going to do this like a normal math problem. Key it in as it's written, 0.0056, and then I'm going to subtract 0.004067, and I hit enter on my calculator, and that's the number that I'm going to get. 0.001533. All right, 0.001533. So now I've got to figure out, how do I round it? How do I make sure that my final answer is not more precise than my least precise measurement? My least precise measurement here is right here. That's the one with the least amount of digits after the decimal spot. So if I look at the number, I've got 4 digits after the decimal place. Notice what I said. I didn't say 4 significant figures. I said 4 digits. There's 4 digits after the decimal. And here there's 1, 2, 3, 4, 5, 6. There's 6 digits after the decimal there. So when I report my answer, I need to make sure that it matches the least amount, and that's 4. So there's my 1, and there's my 2nd, and there's my 3rd, and there's my 4th. There's my 4th spot. So I need to round that number at that location. So there's a 3 that follows the 5, and that 3, of course, does not get the 5 to round up. So my final answer here is 0.0015. All right. So that is the way that we handle this idea of addition and subtraction in terms of significant figures. All right, so we can keep this up. The rules are not going to change, but if you want some more example problems, folks, I can give you example problems all day. So if we look at more example problems, let's say that we've got 146.20 grams, and we are going to add 23.1 grams of water with that. And that's a 2, not a 3. So 23.1. Same thing. Rules haven't changed. Addition and subtraction, pretty straightforward. I take the number as it is, 146.20. Let me clear that out. So 146.20. And then I'm going to add 23.1. And I get 169.3. Right? That's what my calculator told me. So I write it all down. So now I've got to figure out, well, how do I round it? I have to make sure that this is appropriate in the scientific world. So this is addition. And I'll look at the number of digits after the decimal. There's 2 of them. The number of digits after the decimal, there's 1 of them. So I need to make sure there's only 1 digit after the decimal. And folks, sure enough, there's only 1 digit after the decimal there. So that means the appropriate answer here is 169.3. There's 1 digit after the decimal, and that meets the least amount and the individual measurements that made that calculation up. Okay? All right, and let's do another example, but this time let's do more than 2 measurements that get added or subtracted together. Let's say that we've got 156.4, and then we're going to subtract 23.8, and then we're going to add 101.221, and then we're going to subtract a 18.5564. I can do all of that. Doesn't make a difference. The order of operations actually tells me I can do this in whatever order I want to do it in. I'm just going to do it kind of as we go down the thing. I'm going to show you how easy this is as well. It looks complicated, but it's not. So I'm going to key the numbers in as they're written. 156.4, And then we are going to subtract 23.8. And then we're going to add 101.221. And then we're going to subtract 18.5564. And then I hit enter. And I get 215.2646. That does not violate the rule of mathematics. That is how you would solve that math problem in a math course. First one minus the second one plus the next one minus the last one. There's no order of operations that I need to follow here. It's all addition or subtraction. All right, now, if that's my answer, I got to figure out how to round it. How do I make sure it's proper in terms of the scientific field? So I look at these values. There's 1 digit after the decimal, 1 digit after the decimal, 3 digits after the decimal, and 4 digits after the decimal. So when I report my final answer, I have to use the least amount, and that's 1 digit after the decimal here. So 1 digit after the decimal, it needs to be rounded right there after the 2. There's my first digit after the decimal. There's a 6, and that 6, of course, makes that round up to a 3. So 215.3 is going to be the proper answer to that calculation. All right, so that's how we handle addition and subtraction. Now, there's another set of rules that we have to go by with our other set of calculations, and this is multiplication or division. It changes on me a little bit. It still used the least amount, but it changes on me slightly. And we're going to do some of those examples to see how that's going to be done or handled. So let's say that we've got a 0.00569, and we're going to multiply that by 0.91. All right, so I want you to do this in a calculator. I mean, again, it's basic math here. We're not changing those rules. So whatever is there needs to be there. That's not going to be a problem for me. I just need to figure out how to round it off. So 0.00569, and I'm going to multiply by 0.91, and I'm going to hit enter. And this is the value that I'm going to get, 0.0051779. Okay, so let me just write out that answer, 0.0051779. So if this was addition or subtraction, I would look at the total number of digits after the decimal place. But this is multiplication. It's a different set of rules, and that's where we have to be careful. So with addition and subtraction, it's all about total digits, not significant figures. With multiplication and division, we are looking at the total number of sig figs in each of the measurements. And this goes back to the basic rules of sig figs that we've already learned in the previous video. So here in the very first number, I've got a 0 and then another 0 and then another 0. So ding, ding, 5 counts and everything else after counts. So that's 3 significant figures. And then here, that 0 does not count. It's a leading 0. So ding, ding, 9 counts, and the 9 and the 1, there's 2 sig figs. So I use the least amount. Just like I did with addition and subtraction, I use the least amount. And the least amount is going to be a 2. So when I report my answer, I need to make sure there are a total, I'll say that again, a total of 2 sig figs. So leading 0 doesn't count, leading 0 doesn't count, leading 0 doesn't count. Ding, ding, there's my first sig fig. There's my second sig fig. And that is where I need to round this number at that spot. That would be my second sig fig that I need to report. So when I do this rounding, it's going to be 0.0052. And that is going to be the appropriate number of significant figures for that calculation. All right. Division's done the same way. Not a big deal. So let's do 9863, and I'll put a 0.1 And then let's divide that by 876.9. All right. Again, basic rules of math don't change. Use your calculator and key in those values just as they are written on a sheet of paper. So 9863.1, and then we're going to divide by 876.9. And then I hit enter, and there's my number. Please do not ask the question, how many decimal places do you want us to keep? Because I'm going to say significant figures will tell you that answer. You should know how to report this answer. Do I want every single digit after the decimal place? For goodness gracious, no. That's not what we want. We want significant figures to be able to answer that question for us. So there's the answer. I'm not going to write down that number. I'll write down part of that number just so that we'll have some digits on a sheet of paper, but I'm not going to write down the entire thing. All right, so over here, the answer for my calculator is 11.24769072, and that's where I'm going to stop. So the rules of multiplication and division. I look at this top value, and I do total number of sig figs. All right, 1, 2, 3, 4, 5. Every one of those are significant. So 5 sig figs are going to be there. And then I look at this bottom number, 876.9. Well, I start with the 8. Everything else counts. 1, 2, 3, 4. There's 4 sig figs that are here. So that means in my answer, I need 4 sig figs. So ding, ding, there's my first one. It's a number. It has a decimal place. I start with the first non-zero and everything else counts. That was the rule. So there's my first sig fig. There's my second sig fig. There's my third. And there's my fourth. So this is where I need to round that off. So when I do this calculation, I'm going to report an answer. And that answer is going to be 11.2. And that 7 makes the 4 round up to a 5. So 11.25. This is a total of 4 sig figs, and my least precise measurement also had 4 sig figs. Okay? All right, so that's how we do multiplication and division. So let's do another example. And this time, just like we did in addition and subtraction, let's take a look at maybe more than 2 digits. That doesn't really change anything. So 11.2, and then we're going to multiply by an 8, and then we're going to multiply by a 0.9 or 0.0093. All right, not a big deal. I bring out my calculator. Probably can't do that in my head. And I'll do 11.2 multiply by 8, then multiply by 0.0093, and this is the answer that I'm going to get. And I need to figure out how to round it off. All right, so I'm going to write down maybe all the digits here. They're not that many. 83328. So based on the measurements that I've taken in the laboratory, this first measurement, how many total sig figs, because this is multiplication and division. There's 3 total sig figs here. How many total sig figs with the 8? There's just 1. How many total sig figs with the 0.0093? Well, first non-zero digit, it starts with the 9. So only the 9 and the 3 are going to count. That's 2 sig figs. So that means that my answer should only have 1 sig fig, and that is it. It's the least amount that's in my measurements. So here in the number, I need to round it at that spot, because remember, you start with the first non-zero digit. So that leading 0 does not count here. So 8 is going to be the very first significant figure, and the number after that's a 3. So that means that it will not round up, and my answer will be a 0.8. And that's going to be the final rounded answer for that calculation. Okay, so now let's do another example. And this is going to combine probably the addition and subtraction as well as the multiplication and division. So let's say that we've got some measurements in a laboratory and we have 0.0630, and we're going to add a 2.3, and then we're going to divide all of that mess by a 6.28. Right? What would that calculation be? So order of operations happens first. And with the order of operations, you do everything in parentheses first, and you simplify it in baby steps. So here we have to be careful because the top is addition, and that has a different type of significant figure rule. And then the bottom number is going to be divided, and that division will have a different significant figure rule. So with these, I do suggest that you do them in baby steps and simplify them down little bit by little bit. It's okay. That's what pencil and paper's for. Don't skip steps, because if you skip the steps, you'll end up getting the wrong answer. So that means I'm going to start with the top first. I do my everything in parentheses, and that's in parentheses, so I do that first. So I'm going to key in my calculator 0.0630 plus 2.3, and then I hit enter. And this is the answer that I'm going to get, 2.363. All right, so I've got to figure out how on earth do I round that number off. If that's my answer, how do I round the number off? Well, this first digit measurement has 4 digits after the decimal, and the second one has 1 digit after the decimal. So that means in that addition problem, my answer should have 1 digit after the decimal. If I look at my answer, that's going to stop at the 3. So the number after the 3 is a 6, and that 6 makes that round up to a 4. So the 0.0630 plus 2.3 is actually going to give me a calculation or a calculated number of 2.4. And that's what needs to go there. Then we're going to divide that by 6.28. Now we've got a division problem. Now the rules of division show up. All right, well, that's okay. I'm going to now key in my 2.4, and then I'm going to divide by 6.28. And then I hit enter, and there's the value that I'm going to get. It's dividing, so I take a look at the total number of sig figs. So there's 2 on top, and there's 3 on the bottom, which means my answer should have 2 for the final answer rounded. So the 0 does not count. The 3's my first one, the 8's my second, and that 2 does not round the 8 up. So 2 significant figures, 0.38. And that's going to be the proper answer to that particular calculation. Now let me show you what people will do. They'll get into a hurry, and they'll key in their calculator 0.0630 plus 2.3 divided by 6.28, and they hit enter. Notice that's a completely different answer. And that's because the order of operations has not been keyed in the proper way. Your calculator doesn't understand what you wanted to do in the order that you want to do it in. Even though that you paid $180 or $200 for that calculator, it doesn't understand it half the time. So it's up to you to do these in baby steps. Do the things in parentheses first, then do your multiplication and division, and then any remaining addition or subtraction that happens after that. And that's exactly what we did here. We did parentheses first. That simplified the top number to 1, 2.4. And then we took 2.4 divided by 6.28 for a simple kind of calculation, run-of-the-mill division problem. The 0.4292, that's because it only divided the 2.3 by 6.28. And then it added the 0.063 on top of that number. So the calculator has a complete misunderstanding of what you wanted it to do. All right. Another thing that happens here is that you might know the order of operations has to take place. So you'll key in 0.0630 and you'll add 2.3 onto that number and you give me 2.363. You keep that number in there and then you divide by 6.28 and then you hit enter and then that's the number that you're going to give me. And then you look at this and say, well, the least amount of significant figures looks like there's 2, and then this 2 is going to round up to a 0.38 because the 6 makes that one round up to a 7, and you'll give me a 0.38. You just got lucky in this example because it doesn't work out that way every single time, right? You really do have to stop and pause and determine the number of significant figures with each addition and subtraction or multiplication and division as you do these problems, unless they're all the same. If I had 15 different numbers, all of them are divided and multiplied, then I can just key them in all at one time like we did in that previous example, and then just figure it out that way. But if it is a mixture of addition and subtraction, as well as division and multiplication, then we do have to do them in individual steps. Otherwise, we take the chance of getting the answer wrong. We're going to round it wrong, and that provides a wrong answer as a final result. All right? Okay, so that's the deal with doing calculations with significant figures, addition and subtraction, as well as multiplication and division. We do try to keep it simple. We don't go crazy with these calculations and these values. You might see a little bit of order of operations on the worksheet. If this is something that you're not very familiar with or you're not comfortable with, that's okay. Let me know, and then I'll kind of explain what we do as far as how to handle that type of situation goes. But with that said, that's where this video is going to stop. Welcome to the world of significant figures. We do like for you to report significant figures whenever you can, especially in a laboratory environment, because that's what this is all about. We can't be more precise than our least precise measurement, and our calculations have to represent that. All right. So with that said, good luck on the significant figure portion of the assignments. I think that this worksheet will go very fast for you without a problem. But if you do run into problems with some of the calculations especially, let me know. That's what we're here for. So don't be bashful. Answer or ask your question. And again, no questions are stupid questions. That's why you're taking a class. That's why you're paying tuition money in order to learn. And you can't learn unless you ask questions sometimes. And that's what this is all about. All right, so good luck to you. If you need help, let me know.